Hi all, this is Mundan Raghavan. Today topic is normal distribution. So in the last couple of videos we have seen the standard deviation, mean, mode and other things. So now we will see the distribution. So basically it talks about the probability distribution. So first we will see the definition, normal distribution. The normal distribution, also known as the Gaussian distribution, is a probability distribution that is symmetric about the mean, showing the data near to the mean that are more frequent in occurrence than the data far from the mean. So when considering the normal distribution, we will focus on main 2 points. One is like mean, another one is the standard deviation. So we saw what is mean and what is standard deviation in the last videos. So once again, we will see that standard deviation tells you how tightly your data is clustered around the mean. So properties of normal distribution. So the graph of the normal distribution depends on two factors, as I told earlier, the mean and the standard deviation. So mean will be in the center point, which is shown as x bar. The mean, mode and median are all equal in properties of normal distribution. So which means that in normal distribution, if you know the mean, it will be same as mode and median. And curve is symmetric at the center. Symmetric means if you see right hand side, it will be equivalent to the left hand side. It will be same like a mirror image. And second one, exactly half of the values are to the left, center, exactly half of the values are to the right. So the same way what I mentioned earlier, so it will be like a mirror image, left side off will be the same equal to the right side off image. And the total probability will be 1. So whatever you have the probability distributed, so at the summation will be 1. That's why the total area under the curve will be 1. And the main rule is here. So from the mean, right hand side, if you go one standard deviation, 34%, and one standard deviation left, it will be 34%. So which means that from the mean, both sides, if you go one standard deviation distance, then it will cover 68% of your data. The same way, other data are 13.5 and 13.5, and after the 2.5, 2.5. So it will be measured with the help of standard deviation, one standard deviation, two standard deviation, three standard deviation. And on the left side, it will be minus. So from the mean, it will be minus with one standard deviation, two standard deviation, and three standard deviation. Next one, standard deviation determines the height of the graph. The mean of distribution determines the location of the center of the graph. So the center point will be decided by the mean. For the given data, you will calculate the mean, so that will be the center of the graph. And standard deviation determines the height of the graph. So let's say the standard deviation is 5, means it will be from left side 5, right side 5. If it is standard deviation is 10, means the left side 10, right side 10. So based on the standard deviation, the height will be decided. The small standard deviation will have the more height, and the large standard deviation have the less height. So you can see the difference in the given example or the diagram. Next one, normal standard deviation. As I told earlier, there will be two main parameters. One is mean and the standard deviation. And we want to calculate the value x are being standardized. So that we will mention in the formula x minus mu by standard deviation. And in the standard deviation formula, so the mean will be 0 and the standard deviation will be 1. But it's not real in the real time example, so it will vary. So next one, we will see in Python how we are calculating normal standard deviation. So we will see one example. The distribution of heights of American women age 18 to 24 is approximately normally distributed. So here we can get the keyword normally distributed with the mean of 65.5 inches. So the mean is 65.5 and the standard deviation is 2.5. So from this we can note down the center point of the graph will be 60.5 and one standard deviation in the right side will be 2.5. The same way for the left side we need to minus 2.5 from the 65.5. So for this we have the module in Python named SciPy, so SciPy, and we will import the norm functionality from the our module. So let's say we are having three values here. So 68, the value I want to know is 68. So if I use that functionality, what I will understand is 58 to 68 in the graph, the entire area will be given to us. So that's why I'm giving the value where I need to draw the line. So in this diagram, I am drawing the line, straight line at the 68 point. And 65.5 will be the mean value and 2.5 will be the standard deviation. And here, as of now, we will consider only the cumulative density function, which means that if I give one point, so till that point and less than that point, we will get all the density or the probability distribution. So in our case, we will give the point 68. So what does it mean is the point 58 to 68, the entire area will be covered from the output of this CDF command. So let's say the print norm CDF, I am passing the value which I need to get. So it will be 68 and the mean and the standard deviation. The same way, if I want to get more than 68, let's say the highlighted area, orange highlighted area. So total probability area, we know that is 1. And we will get the values from 58 to 68 by using the above formula. So if I want to get the remaining thing, so 1 minus 58 to 68, which is above formula result, we can get the remaining area, which is highlighted. If you have to know about the values in between, so let's say I have two in between values, then how can I execute? So for example, I want to know between the area 66 to 68. So what I will do is, first I will get the area between 58 to 68 and I will get the area from 58 to 66. From the first results, if I minus the second results, you will get only the area between the 66 and 68. So this is the Python demo. So I'm just importing the first line, I'm importing the norm module. Then after I'm passing the values, I'm I'm assigning the value 68, 65.5 and 2.5 to the value mean and the standard deviation. Next I'm getting the value 68. So till 68, what is the total area is, or percentage is 84.13 percentage will be covered in that area. If I want to know the remaining area, so 1 minus the above result will be the 15% will be the remaining result. The same way, if I want to know 68 to 63 in between gap, so it will be 68. So actually 68 and 63 will be the one standard deviation to the right and to the left. That's why we are getting 68%, which we saw in the earlier slide. So that's all about this. Thanks for watching. Subscribe my channel.